All right, guys, we are here today to talk about comparing more complex data sets and comparing maybe two different data sets. So the first kind of graph that we're going to talk about making is a scatter plot. If you guys want to follow along while we create these graphs, you're going to need the link to example data 1 is that natural disaster data, as you can see there. And then you have the global temperature anomaly data right here. Our example that we're going to work through today, I'm going to try and answer the question, is there a relationship between global temperature anomaly and the occurrences of drought? So I think that maybe from what I have learned in studying environmental science, that maybe as the global temperature anomaly increases, so temperature anomaly is the difference from a baseline temperature. And so we have some temperature anomaly, the average, the median of that temperature anomaly here for the whole entire world, as well as by each year from 1850 up until I think 2019. Yep, 2019. And then we also have the upper measurement of that and also the lower measurement of that. So my two data sets that I have are the temperature anomaly, global temperature anomaly, and then I also have that natural disaster data from the first set up above. So I would put those two things here, and in my temperature anomaly, I have the location, so there's global, and then you can also separate it out by hemisphere. You have northern and southern hemisphere. The year, the median temperature anomaly, the upper temperature anomaly, the uppermost temperature anomaly, and the lowermost temperature anomaly. So that's what I would put here in my list of variables. And then in the natural disaster data, I have the years, I have the types of disasters, so droughts right there, and then I have the count of those disasters there. So my chart decision tree here that we have, so I am trying to look and determine whether or not there's a relationship between two variables, so temperature and number of droughts. So that leads me, so I'm looking at a relationship for two variables, so that means I kind of want to see if there's or I want to use a scatter plot. So I'm going to make a new tab here. So I'm going to put in my drought data and then my temperature data, and I'm going to filter my data here so that I can choose just droughts. Okay, and I'm just going to copy all of that data. If I want to copy the whole data set, I can hit Command Shift and down if I'm on a Mac, and Control Shift and down if you're on a PC, and then copy it with the Command C or the Control C. And paste that over here. And actually, I think that our independent variable is probably going to be temperatures, because I think that that might be our causing factor. So I'm going to put that in the columns A and B and C. And I'm going to put my drought data over here. Okay. So I have, and then I'm going to copy my temperature data over. I just want the global temperature because the natural disasters is for all of the entire world. So I'm going to filter that by just global. So I don't have any other data there. And then I'm just going to take the average. So I'm going to look at the data for the whole entire year, or for the whole entire world, and my natural disaster data starts in 1900. My temperature data starts in 1850. So I'm going to just copy from the 1900 data on. Maybe. Okay, there we go. All right. So, and I just want the median. So I'm going to highlight those two cells and then do my Command Shift down to get all of the data from that point onward, or Control Shift down if you're on a PC, and copy. And then paste that information here. All right, so this is temp here. All right. And I might have to do a little bit of data, fixing my data. So I want to make sure that my year for my temperatures matches up with the year for the drought events that we have. And so I'm just going to delete the cells that we don't need. And I'm going to shift the rest of my data up so that it matches there. So it looks like we have every couple of years there. So delete cells, shift. All right, so it's always really important to check your data and make sure that it lines up. So now we have all the same times there. All right, so then we double checked and we made sure we had all the same years. All right, and so we just want to graph the median temperatures and the number of droughts. So we want to highlight all that data. So again, that Command Shift down will get all of it, or Control Shift down. And then we want to insert a graph. So we're going to insert chart either using this little icon or going to the insert chart. All right, so Google thinks that we should do a line chart. I think we should not. We already determined that we wanted to do a scatter plot. So there we go. And we have our temperature anomaly on the x-axis and the number of droughts over here. And so basically what this has done, you've basically told the computer to graph each one of these as an XY point. So our temperature anomaly was our X coordinate and our Y coordinate was the number of droughts. All right. So we can customize it. Maybe change our title a little bit. So this is our global median temperature anomaly versus drought occurrence. Okay. And then maybe I want to make this a little bit more formal here and put number of and type out number. So that's our vertical axis. Number of droughts. There we go. It's hard to type in the little degree sign, so we're just going to skip that and leave degrees Celsius there. Okay, and then we want to look and see if there is a relationship. So if you look at this cloud of dots, I mean, maybe there might be kind of a trend going this way. A little bit of one. So we're going to try and insert a line of best fit. There we go. And we do that under the series drop-down menu here. And we want to add a trend line. And we want it to show the R-squared value. So that shows us in the legend. The R-squared value is the proportion of our data points that can be explained by our model. And our model in this case is the equation of that line. So in this case, a linear trend line gives us an R-squared value of 0.46. So that means about 46% of the variation in our data, so of the data that kind of the data that moves around, can be explained by this line. So that's not really a whole lot of our data that can be accurately explained by that line. So that doesn't give me a whole lot of faith in this line of best fit. So it's not really a great fit. We can look and see if maybe another, so we're usually looking for something in natural sciences that's at least above 50%. But maybe closer to like 70 or 80. for that, or 0.7 or 0.8 for that R-squared value. In more controlled experiments, like in chemistry to explain a trend, or maybe in like pharmaceuticals, which is just chemistry applied, you might be looking for an R-squared value that's much higher, like closer to 0.9 or something like that, so that 90% of the variance in your data can be explained by that line of best fit. So we can look and see if so we're going to look and see if maybe different types of lines might have better fit for our data. So we looked at linear before, and then exponential, and that has an even lower R-squared. So we're down to like 34-35% of our data. 46%, 20%. All right. So it turns out that that linear is indeed the best type of line. It gives us about 46% of our data, the variance in the data that can be explained by that equation of that line. We want the name of the trend line to be the equation of the line. Oh, or not, for this case. It might be helpful if you're writing a more technical paper. Okay, so we'll leave it like that. And then we can take our graph and insert it into our document and also into our class slides. And then when we're interpreting this data, because our line really doesn't have a good fit to our data, we can't with any confidence say that there is much of a relationship between drought and temperature anomaly. And that's fine. That's what our data tells us. So, and we would say that because over half of our data, the variance in the data cannot be explained by this trend line, then that's not a very strong trend that we see there. Some questions that I might still have about this data, I might want to know, like, why didn't we have data for every single year of droughts like we did for temperature anomalies? And because maybe more data points would have given us a better trend line. And maybe like, what's the criteria, like who's reporting the droughts? So did the number of droughts actually increase over time, or did just reporting of weather events and recording of weather events increase over time as countries developed and found that valuable? So just some interesting things to kind of maybe look at later. All right. Thank you for watching this video, and I look forward to talking to you guys about this and seeing your graphs.